Okay, here's the target 6A retake. It's on the triangle inequality. So the triangle inequality says that the largest side of a triangle has to be smaller than the two smaller sides added together. So to find the possible range of values, we add the two sides together. That gives us 25 and 32, and that's 57. And then we subtract them as well. So 32 minus 25 is 7. Okay? So the range of values for the third side has to be between 7 and 57. So it has to be between 7 and 57. So the third side has to be between those. So if it was under 7, like say 6, then 6 and 25 is only 31, which wouldn't be bigger than 32. So that's why 6 doesn't work. And then if I pick something bigger than 57, like 58, 25 plus 32 is only 57, which is not bigger than 58. So that's how you get the range, is to add them and subtract them, and then the third side has to fit between them. Okay? So now for part B, we just have to list 5 values that fit between 7 and 57. So we could pick 8, 9, 10, 11, 12, right? I could pick 23. There doesn't have to be any order. I could do 17 and a half. I could do 19.3. I could do 56.9. As long as it's between 7 and 57, I just have to pick 5 numbers that are between 7 and 57. They could be whole numbers, they could be fractions, they can be decimals. Okay? Alright, next slide. So we have to sketch a triangle with side lengths 9, 12, and 15, and it has angle measures 37, 50, and 53. And then we have to find and label the third angle. So before we can draw it, we have to figure out the third angle. So we're going to take 37 and 53. Can't read that. 37 plus 53 plus x equals 180, because remember the triangle sum is all the angles of a triangle have to add up to 180. So when I add these, I get 90 plus x equals 180, and then I subtract 90, and I get x is 180, 90. So I know that the missing angle is 90. So I have to draw a right triangle. So I'm going to draw a right triangle. And it doesn't matter which way you make it. I'm going to make mine looking like that. So I know that that's 90. Okay, now I'm going to put the sides in before I put the angles, except for the 90. So I want to put the smallest side on the side that looks the smallest. So this side right here, that looks the smallest. So that has to be 9. The longest side is always a hypotenuse, so that's 15. That's right here. Okay. And then the middle side would be this side right here, which is 12. So, and these are meters. 9 meters, 12 meters, and 15 meters. Okay. Now I have to put the angles in. So the 90 has to be across from the hypotenuse, so that's right. Now the smallest angle, which is 37, has to be across from the smallest side. So the smallest side is 9. So right in here, that angle has to be 37. And then this angle has to be 53. And then I'm going to erase my arrow. Anyway, so 37 here, 53 here. So the 37 has to be across from the 9, the 12 has to be across from the 53, and the 90 and the 15 have to be across from each other. Okay? Do the side lengths 8, 15, and 23 centimeters form a triangle, and explain your reasoning. So again, remember the two smaller sides added together have to be larger than the third side. So what's 8 plus 15? Well, it's 23. Is 23 bigger than 23? No, it's not. 23 is not larger than 23. So a triangle with side lengths (8, 15, and 23) is not possible. Okay? So remember, you add them together. If it's equal, it's not possible. If it's smaller, it's not possible. And if it's bigger than the biggest side, then it is possible. Okay, so the following problems you have to show a math lab teacher, a geometry support teacher, or your geometry teacher, and have them checked, and then you can do the retake. Okay, so the first one, a triangle has side lengths 19 and 54. Find the range of values for the third side, and list the 5 values for the third side. Okay. Number 2, sketch a triangle with side lengths 7, 24, and 25 with angle measures 16 and 74, and then you have to find and label the third angle. And lastly, number 3, do side lengths 12, 28, 23, form a triangle. Explain your reasoning. Okay? Good luck.